Good morning, children. Today our topic is covalent or the molecular bond. Okay, we have already learned the ionic bond, so we are going to start with the covalent or the molecular bond. And you know what is meant by a covalent bond? A covalent bond is a bond which is formed due to the sharing of electrons. Okay, the bond which is formed due to the sharing of electrons, we call it as the covalent bond. Okay, these covalent bonds are formed between the non-metals. It is formed between the non-metals because usually non-metals has 5, 6 or 7 electrons except this carbon and hydrogen, which I have shown in the parenthesis. Carbon has 4 electrons in its outermost shell, whereas hydrogen has 1 electron. So these elements tend to share their electrons to form a molecule. So it is called as the covalent or the molecular bond. Okay, now the important concept in this is each atom contributes equal number of electrons. Each atom contributes equal number of electrons. So it is called as mutual sharing of one or more pair of electrons. So when a non-metal combines with another non-metal to attain the stable electronic configuration, the sharing of electron takes place. Because of the sharing of electrons, they form a covalent bond. For example, let us take the bond between hydrogen atom and hydrogen atom to form hydrogen molecule. Now you can see that when hydrogen and hydrogen combines to form a H2, it has to be H2 there. When hydrogen and hydrogen forms a H2, there is a sharing of one pair of electron takes place, forming a single covalent bond. Forming a single covalent bond between hydrogen and hydrogen atom to form a hydrogen molecule. Now let us go to the next one. What are the different types of covalent bond? Okay. Now you can see there are 3 different types of covalent bond. One is single covalent bond, double covalent bond and a triple covalent bond. Okay, so single bond, double bond and triple bond. A single covalent bond is formed by the sharing of one pair of electrons. It is formed by the sharing of one pair of electrons. Because this structure I have taken because already we have learned the structure of methane. I think you all remember from the organic compound. The structure is CH4. The first picture they are showing the electron distribution. The second picture you can just see the bonds alone. In green line you can see the bonds alone. So this is the CH4 is the formula for methane. You can see that very clearly in the picture. And here methane is formed by single covalent bonds. Okay, there are 4 single covalent bonds, and when there is a bond which is formed between 2 oxygen atoms to form oxygen molecule. Okay, 2 oxygen atoms combine together to form an oxygen molecule. When they form a molecule, what happens is that a double bond is formed. Why a double bond is formed? You can see that a double bond is formed because 2 pairs of electrons are shared. 2 pairs of electrons are shared. Similarly, a triple bond is formed. Okay, a triple bond is a combination of 3 single bonds. Okay, a triple bond is a combination of 3 single bonds. So here in the picture you can see nitrogen forming 2 nitrogen atoms forming a nitrogen molecule. There is a triple bond. Okay, so types of covalent bonds is there are 3 different types of bond. One is single covalent bond, double covalent bond and triple covalent bonds. Now let us go further. Again, one more important examples we will see, because for us to understand further, because we have already learned the organic chemistry, I have taken the compounds with 2 carbon. So the first compound is ethane, second compound is ethene and the third compound is ethyne. Ethane, ethene and ethyne is the structure that you are seeing in the picture now. So you can see that in the ethane, or the carbon and hydrogen are bound by a single covalent bonds. In ethene, you can see the combination of bonds. I think you can see the combination there. Number 1 is between carbon and carbon there is double bond, and between carbon and hydrogen there are single bonds. So there are combinations of bonds, that is there are 1 double bond and 4 single covalent bonds. You can clearly see in the picture there is 1 double bond and 4 single covalent bonds. When you come to ethane, ethene, ethine, okay, that is an alkyne. Okay, so we have to revise from the previous one. Ethine, you can see there is 1 triple covalent bond and 2 single covalent bonds. Okay, so what is this covalency? Covalency of an atom is the number of electrons taking part in the formation of the shared pairs. So the covalency of hydrogen is 1 because only 1 electron is involved in sharing. Covalency of oxygen is 2. Okay, because 2 electrons are involved in the formation of the covalent bond. Nitrogen is 3, carbon is 4. That is called as the covalency. Covalency is the number of electrons taking part in the formation of the shared pairs is what we call it as covalency. So we are just seeing it again. Sharing of 1 pair of electron is taking place in a single bond. In a double bond it is sharing of 2 pairs of electrons, and in a triple bond there is sharing of 3 pairs of electrons. So we are seeing the structure of ethane, ethene and ethine now. Okay, now let us go to the next topic, that is nothing but a polar covalent bond. Again, when we classify the covalent bonds still further, covalent compounds can be polar or non-polar. Covalent compounds are non-polar also. There are polar covalent compounds also. What is a polar covalent bond? A polar bond is a type of covalent bond between 2 dissimilar atoms in which the electrons are shared unequally. Okay, a polar covalent bond is a type of a covalent bond in which there is the electrons are not shared equally. We call it as polar covalent bond. Okay, so let us take an example of it. Electrons are shared unequally. There is an asymmetrical electron density, and because of that it results in the partial charges. Okay, this we have already seen in the water molecules also. Okay, when we see into the water molecules, we can see the oxygen has a delta negative charge and hydrogen has delta positive charges. And let us see, okay, to make it more clear, let us see one more example. Here we have taken the example of hydrogen and chlorine. Okay, let us take the hydrogen chlorine compound, that is hydrogen chloride, where hydrogen and chlorine shares 1 pair of electron each. So what happens is that in the sharing of electron is not equal between hydrogen and chlorine. So because of this reason, the shared pair of electron is more towards the chlorine. So because of that, the chlorine gets a delta negative charge and hydrogen gets a delta positive charge. Okay, so this results in the partial charges. Such compounds are only, we call it as polar covalent compounds. Why do this polarity occurs? So let us have the examples here. You can see in this picture polar, non-polar, and that is pure or non-polar, then polar and ionic compounds. So 3 compounds I have given a comparison for you to understand better. This is because of the difference in the electronegativity. I have given a scale also in the below. Okay, when there is a scale below, you can see that when you know what is electronegativity, take your first lesson, revise what is electronegativity also. It's very important. It's a very important question. Okay, now when you see the polar covalent compound, the electronegativity difference is between 0.4 and 2. Okay, the electronegativity difference is between 0.4 and 2. When the electronegativity difference is greater than 2, it becomes an ionic compound. If it is less than 0.4, then it becomes a pure or non-polar covalent compound. So this pure or non-polar covalent compounds are formed between the same atoms. For example, hydrogen and hydrogen combining together to form a hydrogen molecule, or oxygen and oxygen atom combining together to form an oxygen molecule, or a formation of a nitrogen molecule. Such types of compounds, when it is getting formed, they form only non-polar covalent compound. Okay, when you come to polar covalent compounds, this polar covalent compounds, what happens is the electronegative difference is between 0.4 and 2, so they form a polar covalent compound. And you have many examples of polar covalent compounds like water, hydrogen chloride, as already I have explained to you, ammonia, hydrogen fluoride. All these are polar covalent compounds. All these are polar covalent compounds. Okay, in non-polar covalent compounds, as I have already told you, it will be like hydrogen, chlorine and oxygen. All this, hydrogen H2, chlorine Cl2, nitrogen N2, oxygen O2. When the sharing takes place between the similar atoms, then they form a compound called as pure covalent compounds or non-polar covalent compounds. Okay, so with this, let us finish off the lesson of this one.